Hey guys, so welcome to my new lecture. So in this lecture I thought that since I am telling a lot about web development and web, why not clear more about what is internet and how does it work. So if you know the basics of internet and how it works, I think that will be really beneficial for you to understand how the web itself works and how web pages are sent over the internet and the web protocols and how security works, and that will really help you in your web development career. So let's jump right into it. So first of all, I'd like to ask you, what do you know about internet and what is internet? So what is this first all about? So let me give you a great analogy to help you understand what is internet. So suppose there is a society, and inside this society there are a lot of houses. So there is your house, there is a friend's house, relatives' houses, there are a lot of houses, and you can only go to anyone else's house if there is a road between them or a path between them, that is a set of roads connected to each other. If there isn't, otherwise there is dense jungle, and if you go there you will get lost. So if there are roads between those houses, only then you can go to any other house or send some gift to other house. So there are a lot of houses in this society, and there are a lot of roads which are connecting them to each other. So as you can see, if I am living over here and my friend is living over here, so I can use this road to go to my friend's house, right? And I can even send some gift to them, and they can also come later and send me some gift. But this house isn't connected by any road, so you can see no one can reach this house, and neither can anyone from this house reach any other house. So that is one of the basic ideas of internet. But in case of internets, these houses are computers or servers. So suppose you say server, and these are communication systems through which these computers or mobile phones or computational devices are linked to each other. These are the main transport system for them. And but what is sent from one system to another? What is that thing? So it is basically the data which is sent from one computer to another through these systems, through these communication links. But unlike us, it doesn't have an intelligence of its own. We know that this is the path to my friend's house, so I know I have to go through this path and then take this route and then go over here. But so this packet which goes from one computer to another is like a data packet. It is called a data packet, and then data packet has to go from here to here, suppose. So this server will create a data packet and put in the destination's address and put in its own address, so that the destination knows where it is coming from. So source and destination address both are in this packet, and then this packet is sent. But now who takes the responsibility of taking this packet and making it reach to the destination? Because it has to take a different route from here. So if this packet reaches here, there are two other routes that are originating from here, which is going to this computer and to this. So who will do that? So for that, so I'll say this one is not a computer, this is a router. So routers are very helpful and are responsible for routing the data packets to the desired destination. So when the router will receive this packet, it will check the destination and it will know which route to send this packet to, and it will send that packet to the correct path. So apart from end devices that are servers, mobile phones, computers, there are the internet consists of routers as well, which are used to send the packets from one place to another, and that is done in a very efficient and in a way that the path calculated is the shortest. So fine, so this is how the internet is structured, and let me tell you, like, there is no such governing body who governs the internet and its rules. It's just a protocol based idea on which everyone agrees to, and all the companies follow those protocols, and they set up their infrastructures, and that is really what internet is all about. That's what makes it connected to one another. So I've talked a lot about the internet. Now I'll talk about what is actually transferred. So in computer language, anything and everything is represented in binary, which is constructed by zeros and ones. So anything from a picture to a song to a video to an HTML page to a game, an exe, anything can be represented as a binary code. 8 bits of a binary code is 1 byte. So 1024 bytes create 1 kilobyte. 1024 kilobytes create 1 megabyte. 1024 megabytes create 1 gigabyte, and it goes on. So as much as the data, that much the size of the file, right? As that much long would be the binary data. So anything is transferred using bytes. So okay, we understood it. So definitely the addresses of the source and destinations would also be in form of bytes, right? So let me tell you. So any address was initially represented in form of IPv4 address. So the address IPv4 is represented in the form of 32 bits. So IPv4 address is 32-bit address. So it's like 4 groups of 8 bits. So 1, 2, 3, 4, and 8 bits in each of these 4. So the maximum number that can be attained from 4 bits is 127. So you might have heard of 127.0.0.1. So this is an address which is like 1111.000.0000.0001. But when there were a lot of computers and a lot of more systems, 32 bits felt short, and there were not many addresses that could be assigned. So in modern day we have IPv6, which is a 128-bit address. Now any data which is sent from one system to another, that data packet has a limit. You cannot send 1 GB of data at once. So the solution to this was, if the data is large, it is broken into packets, and those packets are sent one by one to the destination, and then when they reach to the destination, it is the job of the destination to reassemble all the packets and then create back the original data. So that's how it works. So we are not going into much detail. Maybe later in some other video we would, but this is like the overview of how it works. A DNS is a domain name server. What is the job of a DNS? As I already told you, the addresses of any computer is in the form of bytes. It's a binary address. Now you are opening the web and opening the browser, and you want to go to google.com or facebook.com, and facebook.com has a particular address, but do you type 32-bit or a 128-bit binary address in your browser's address bar to reach Facebook? No, you just type www.facebook.com and you get the Facebook page. So where does the actual address, which is the binary address, received by the browser, where from it is received? So there comes the domain name server. Domain name server is server which keeps the mapping of these domain names like facebook.com, google.com, linkedin.com, and with their binary addresses, their actual destinations. So my browser would first hit domain name server and ask, hey, can you get me the address of facebook.com? And domain name server would search in its mappings what is the IP address, and when it finds, it will just return back the address, and the browser then will send a request to facebook.com that, hey, send me your homepage. So to send that, to request Facebook, it would need that IP address, and that it has already gotten from domain name server. So that's how the browser is able to communicate to Facebook, and the domain name server comes into picture. But going more in detail about domain name server, so one domain name server would never be enough to contain all the mappings. So there is not one domain name server, but there are many domain name servers which are connected to each other. So what happens, so my computer, when I enter facebook.com, it will request this domain name server for the IP of the facebook.com. So this will search in its own mapping. When it doesn't find, it will ask the connected domain name servers, hey, please find me the IP address of facebook.com. Then they will do the same, and as soon as some particular server has found it, it will return the address to them, to the ones who requested it, and also the ones who have received it from the next ones, they will update their own mappings also, and this will be received by this. It will also update its mapping, and then it will be received by my computer, and that's how it is working. Now the next and the final topic, which I think is important, is to know how is the communication working. I've talked a lot about the communication and how they are linked, but what is the actual medium which is used for communication? So suppose in case of mobiles, we all are using mobiles and they are wireless. So if they're wireless, how are they communicating? So they are communicating through satellites, and they are communicating through radio waves. So actually these are mobile towers. They are communicating through radio waves. Through radio waves, the bits information is exchanged, and those radio waves are responsible for transferring the data. So this is one of the ways for wireless communication. The other one is through electric signals. Now suppose so binary information is transferred like by 0 and 1. So suppose an on electric signal is 1 and an off is 0. Now suppose this wire is sending one on signal, then 0 off, on off, and it is able to get all the information correctly. But suppose it has to send 5 zeros. So 5 offs, how does it identify there are 5 zeros? So for that, there is like a timer which both the sender and receiver know what is the timer, and they agree on that. So suppose the timer is 1 second. So for 1 second there is no signal, so it's 1 0. Then another 1 second there is no signal, so there's another 0. So like that, for 5 seconds no signal, then 5 zeros, then there is a up signal for 2 seconds, for 2 ones. So like that it is. So 1 second, 1 bit per second is too low. So that's why computers have a pretty fast calculation and a pretty low time interval for this, so which won't be possible for humans to interpret, of course, because it will be too fast. But for computers, the time interval is too low, and they receive and send and receive the information like this through electric signals or through LAN wires to say. But it is not very reliable. You might have experienced some miscommunication or broken communication through LAN wires yourself. So now the latest and the most reliable which we use, what can be that medium? So we have talked about radio waves, we have talked about electricity, and which one is fast and reliable? Light is very fast and it is reliable as well. So we use light to communicate and transfer data. Confused, huh? So let's see how we are using light to do so. So there are optical fibers which are engineered to reflect light from inside, So this is suppose an optical wire. Now if I send in a light wave, it will get reflected and it will go on and on till the end. It will reach there, and this is how the whole continents around the globe are connected. There are optical fibers laid beneath the ocean, and they connect the continents, and they are very reliable and they reach each other very fast because it's light. And also if you send the data at different angles, it is interpreted differently. So you can send multiple waves simultaneously, so you are sending multiple data simultaneously. That is another advantage. It's just that it is difficult to work with and difficult to implement, but it is really fast and reliable, although it's a bit expensive. So these days now, like, the whole internet around the globe is connected mostly via optical fibers. A lot of information, huh? So this is like the overview I wanted to give you about internet. So I think that's enough, and so thank you for staying tuned, and please subscribe, like, and keep following, and just stay tuned for more educational videos. Thank you. Bye.